but I still feel like there's, minimal upside here, just because.
I think I've heard you talk about like cryptography regarding quantum and cracking RSA, maybe ECC, maybe factoring discrete logs. So it's there. I'm hearing that it can be very useful for cryptography, but you think we're anywhere near maybe 10 years down the line from cracking these sort of things, or is it just like we are so distant and we're you can put only so much information in a quantum computer, can't really handle these bigger problems yet?
Yeah, I mean, so for factoring, the amount of information is very little, right? And that's what makes factoring so cool is that it's a 300-digit number, but if you were to try to factor it, it would take you till the end of time to do it, which is really neat. That if you wrote that number down beforehand, you say, "Oh, well, here's the answer. I had it all along," and it's basically nature's password, which is really really cool mathematically and scientifically. But so quantum computers don't need that much information. As I just said, 1,000 bits will give you the world record factoring problem. So you don't need, you know, a lot of qubits. We already have 150 qubit machines in IBM's cloud. The thing that you do need is getting high fidelity, so you can actually run the experiment. But I think those problems will start to get solved. There is an outside chance that it just can't get solved. There are some people that think that. I'm not in that camp. I'm an optimist. um, as crazy as that sounds to some people, like I am an intrinsic optimist, but I'm not a fool. Um, so I believe that we will be able to control matter and harness quantum effects to do calculations. But the complexity speed up is really important here. To go from the exponential class of problems to the polynomial class of problems. Polynomial time is tractable, exponential time is not. So that complexity shift is really important. And the only class of problems that has proven complexity shift is Shor's, which is the integer factoring in essence. So integer factoring is not useful to anybody other than code breakers, hackers, maybe nation states. But I can't see for sure, right? But with sustained investment, meaning quantum doesn't go cold again because it's had the cold hot cycles. It's been around 2 cycles now of winter and spring, and we're clearly in spring right now. But I assume we'll get to winter again soon. Um, I see if you assume just sustained investment nonstop without the breaks, I could see in 10 years we could crack state of the art Shores, and that's a big thing. Shore's been around 50 years. GCHQ, which is the UK NSA, had Shores before Shore. I'm sorry, had Shores before RSA. RSA, Rivets, Shamir, and Edelman. They published their groundbreaking RSA paper. I think it was 1979. But the hackers and spies in Britain, the Brits had it in 1975. So the obvious thought here is that these weren't independently discovered. There were whispers about this, and they made it to MIT, and MIT professors, quote unquote, invented this. Just a funny backstory about it. It doesn't matter that much. But RSA has stood tall for 50 years. Now, by the way, you can make key sizes bigger. There's a bit of a pain in the ass that occurs, but we're on 2048 bits. So 2048 bits are big. That's double. That's like a 600-digit number. So if we go to 4096 or 8,000 bits or something, you can even outrun a quantum computer. And then, of course, lattice-based cryptography is already getting standardized out there. It should be as simple as a pip install, npm install package at some point. So I could see very, very soon, people start to implement lattice-based because it should be as simple as implementing RSA. So I think that, everything will be fine. Bitcoin will have to go through some interesting transitions, but the death of RSA is not that crazy. AES kind of died. So, these things do happen. And, there's a first time for everything. Technology is by definition the first time. So RSA will have to disappear, I do think. But I'd be surprised if it happened in the next 5 years. I would not be that surprised if it happened in 10 years, but I also wouldn't be surprised if it happened in 15 or 20 years due to the nature of funding cycles. We're at an all time high of funding. Mostly it's going to AI, but we're at a really, really large funding kind of peak that may dissipate for many years. And in those years, companies hunker down. They don't really do much research, especially smaller companies. Google and IBM may be undeterred, but your smaller companies are wondering how they'll survive. Eventually, winter will thaw, but you can spend 5 years in winter and lose 5 years of progress. So I would not be surprised if it happened in 10, but I also would not be surprised if it happened in 15 or 20, but there was just dead time in there. Um, and again, you have to ask yourself, what's the big payoff here? You know, splitting a number into two is not that exciting. Nobody's job relies on that. So anyway, that's how I feel about quantum. Anybody else? INMB. Let's maybe try to talk about. And thanks for calling.
Yeah, thanks. Thanks.
Where are my INMB fans? Where you at? I know it's embarrassing because, like, if you're not a professional investor,
I
you
mean,
can
while we
feel
wait, just one thing I do want to point out. Um, a huge bear case for quantum could be that, why would Nvidia spend, multi-billions of dollars on, GPU and these huge data centers if quantum computing is such a risk or such a threat? Like, you wouldn't spend billions of dollars on huge infrastructure projects just to be wiped out in 10 years. Like, it just doesn't make sense. But the reason why I bring up my previous points is just because of, things that I've heard and things that I'm just doing my own research as to like the possibilities of it being used. But what are your thoughts? Like, do you think that's like something that's a valid point, or do you think I'm just looking at it from the wrong angle?
Yeah, I don't think it's a valid point because we all know and can think of examples of companies that put their head in the sand and just avoided technological change that said, oh, that'll never work. And pharma said that about antibodies. They looked at these antibodies and they said, wait a second, you're telling me I have to create a microbial system that's alive, that spits out these drugs in this goop. Then you want me to go in the goop, filter it out, and then you want me to give it by IV because you can't do it orally because it's a protein. You want me to give it IV to a patient. It can't go intracellular. It can't cross the blood-brain barrier, but somehow this is going to be useful as a medicine. I mean, Pfizer and Merck said, well, you got to be fucking kidding me, right? Anything you guys could do, we could do with small molecules. Now, they were wrong. They didn't adapt. They didn't change. They had to be mentally flexible. And it's just something that forced them to become left behind. So technology is full of stories like this where, people have just, forgotten to advance with time. I don't think NVIDIA is one of these companies. I think NVIDIA is a company that is very smart and they're going to figure out what to do with quantum, if anything. But I also think that it's not it's not beyond the pale. It's not impossible that NVIDIA simply just does nothing and makes a mistake, whether it's quantum, probabilistic, DNA computing, it could be anything. So I wouldn't just rest on NVIDIA is so smart, they're doing nothing, therefore it's nothing. Microsoft missed AI, and rapidly caught up, but Apple completely missed AI, and they're smart. But so there's a number of cases in technology where it's just you can't just say these guys are so good that how could they miss it? Now, obviously, I think it's fair to say that like most of tech is not that excited about quantum. The IBM effort and the um, Google effort, and certainly a little bit the Microsoft effort. They're semi-serious. They're kind of side projects for those management teams. They look at it for a small period of time, maybe once a year, and then for focus on their main business. But you know that's why they're moonshots, and most of these moonshots don't come. Nothing sort of comes of it. It'd be fascinating to me if IBM, you know, broke out quantum revenue, started talking about it every call, and was really fixated on it. But I think that it's really just a sideshow, and most management schools will tell you these days to avoid sideshows. And I'd be surprised if at some point Google or IBM kicks quantum to the curb. Google is now trying to figure out how they stay relevant in the world of AI. They're very good at AI, but they also are not very good at executing. So I think for Google, it's a distraction, but they silo it good enough that it doesn't distract management. I think management doesn't even know what the fuck's going on in quantum.
And just to follow it up, if you were speaking to like your typical like quantum investor, whatever, like person that just downloaded Robinhood and is tossing, their $50 whatever allowance or whatever into this, like if you can explain in a few sentences to that person why quantum does not have a future in very like layman's terms, what would you say to this person without having them to, sit down and listen to like a full 40-minute conversation? What would be your main driving point?
Yeah, so I've done this in the Shea interview, but basically quantum is a distant technology that solves a very narrow use case. The narrow use case is the set of algorithms that are speed ups in complexity classes from largely from exponential to polynomial. Running an algorithm in polynomial time is vastly preferential to running an algorithm in exponential time. Quantum effects allow you to do that by taking advantage of things like entanglement and superposition. But unfortunately, the only known quantum algorithms which take you from exponential time to polynomial time are Shor's algorithm. Shor's algorithm is only relevant for factoring. There's other algorithms, but their speedups are much, much less. Between the distant time it's going to take for quantum to come alive and the very narrow space of computing that it can do, for example, it cannot do AI, it cannot do anything with large amounts of data. It can only do this really, really narrow space of problems. You'd have to be confident that either there's going to be more problems that can be solved, but if you read the literature, there's not much hope. The last major quantum algorithm that was discovered was 25 years ago. There's not much hope that there's going to be another one. In fact, Shor's discovery